Thanks. It's a pleasure to be here. The weather is quite better than compared to the last PasswordsCon in Oslo. I mean, it was.
Oh, come on!
Still in these rooms, it's a bit cold, so sorry for wearing this black hat shirt, but yeah. My name is Marco Voigt. I'm heading the European research team in Europe. I was just talk about some project I've done recently. I mean, not recently, it started already in end of 2011, something like that. But by speaking about the past a bit from last PasswordsCon, let's just dig a bit further in the past, in the beginning, to the year 1646, where this nice guy was born. I hope everybody of you recognizes him. Antoine Galland. I hope it's spelled correctly. I'm not French, I'm German, so maybe there's some mistakes. And this gentleman did some very interesting thing back in 1704. He translated a very old book. To that one? Oh, nice. As I said, this guy did some translation back in 1704. I don't want to waste too much time by talking about history, but this one was very important. It was a book from the year 250, so very, very old. And it was called the 1001 Nights, also known as the Arabian Nights. Maybe you all know this fancy story about Alibaba getting the password for the secret treasure cave from the 40 thieves just by hiding behind the cave. I think this is one of the earliest occurrences of a password thief. And I mean, nowadays OpenSesame is not a very complex password. And when you just compare it to what we have now, these treasure holes, these treasure caves out there, there's quite a lot, and people are not just hiding behind the caves anymore, but there are a lot of leaks. I mean, you follow the news all the past years, there are many, many, many leaks out there. Hundred thousands or millions of passwords and credentials were leaked. And this is just a short summary of a few of them. The bigger the circle, of course, the bigger was the leak. And this brings us to the point where are these leaks published. And some of them rely on some very old service, speaking from today, from paste services. Some of the first paste services called Pastebin, which is one of the biggest ones, was established in 2002. And nowadays we are roughly more than 100 paste services online for different things, like some just focusing on some projects or source codes, and others are more generic. So you find a lot of different stuff in these paste services. Just a few examples I collected, found a lot of source codes or even code snippets, which is even worse. I mean, just code snippets, a few lines of unrelated source code you don't know what it's doing, or just it's to show some stuff. Also, you have a lot of manuals posted, advertisings. I've seen a lot of stuff like advertising for premium cookie services, or for other services like not gray area services, black area services, how-tos, and of course also a lot of snippets from IRC and chat logs, links, torrent links, a lot of advertising for rare stuff, pirated stuff, and of course leaks and password lists. And that's something we're probably interested. So there's the data. Let's get it. But paste service, 2002. There must be quite a big collection of paste stored on these services. Yes, when we just look it up, officially Wikipedia says that pastem.com has more than 20 million active pastes. I mean, 20 million, when you just want to download this manually, you will go nuts in front of your computer. It's just not possible. So, what will you do? Of course, you create a bot. You create a bot to save your life, to make your life easier. But creating a crawler or a bot, I don't know if anybody of you have done this in the past, it's not so easy. There are quite a few problems. Let's go to the first. The websites will of course recognize you after some time when you reach tons of megabytes or gigabytes or whatever, that hey, this guy is scraping our website, so he's creating a lot of traffic, we have to pay for this traffic. Not good, so they will just direct you to some access denied or whatever websites that you don't get anything. Or when it's getting worse, you may even be recognized as some kind of a DOS attack, or when at that time a lot of people want to access this data, you may be part of some sort of DDoS attack and will be redirected to some anti-DDoS services, and that's it. So what will you do about it? You have to think about your IP address. Just as a side note from me, some people think going to Tor makes life easier. In this case it doesn't, because Tor in this case is too slow and not reliable enough to really use it for crawler services. You have to think about your user agent. I mean, user agent is one thing you can be identified with. The referrer, of course. So if you don't have a referrer and just go on crawling, this may be spotted quite fast. And also all these HTTP stuff like cookies, or how these requests and responses are created. Based on this, like public libraries and some scripting languages and stuff are very easy to spot by this ways. And also the time is a very, very important thing. How many requests do you have within a second? In general, golden rule is don't request too much. That's why it's here in bold, because you have to be nice for the people serving the data you're interested in. So in my project, it was quite some evolution. I started just looking up some paste from time to time, and then it became more often and more often and more often. After some time, I thought, okay, let's write a small crawler and download all that stuff on my desktop machine. And then my desktop machine, after a few days and weeks, I spotted, oh, this amount of data is quite a lot, so I put it all on the server and make it a bit more efficient and professional from that point. But there are some more problems. Like pastes may be expired, so they're just there for a certain period of time. So if you wait just 24 hours or something, you will waste half the paste roughly. Or also some paste may be password protected. So some paste services have the functionality that the paste can only be viewed when you have a certain password. Of course, you also get tons of unstructured data. I mean, the examples I showed before, it's just you get crap of everything. And it's really completely unstructured, so you cannot just go there and grab out your stuff you want to create, for example, for Word and stuff. And also you get a lot of trash. Like, not everybody is interested in how that piece of source codes from any language doing some stuff, or HTML stuff. It's just not interesting at all. So you need to add processing. So additional servers doing the processing, because of all the traffic, all the data, you need to somehow process it and extract the stuff which is interesting. And first of all, which is very, very important, when you just handle it, you will clearly see that pastes are not regular files. So everything you do when working and processing regular files are not is not working with paste at all. So I just did some tests. I selected a test set based on time with 184,963 paste. I know it's not a regular number, it's just because this pack of paste was in that amount or whatever. And I first used the Linux tool Pi and tried to check if Pi is able to recognize the different types. And overall, Pi gave me 161 different types. I know it's a bit small. Zoom in a bit. I tried to cluster it a bit, so you have applications, videos, audio files, or whatever Pi recognized. And to be honest, on paste services, you won't find a real video file or audio file, or even D-based files. So Pi 2 doesn't work. The next thing I tried was the genome database. This is quite interesting because it's more actual, and just when you work on genome Linux system, and open Nautilus or some other Pi browser, you can see that the Pi recognition is based on this database and is very more accurate than compared to the common Pi utility. But even that one gave me 72 different types and also video files and audio files, so also not really good. And when you just correlate both of these different detections, you will clearly see that you have a lot of different, let's say, clusters or categories in this area, which do not match when you compare it to Pi and genome database. So you cannot even use those tools and just correlate and extract the interesting stuff because it doesn't work at all. But why should I care? The important thing here is you get tons of data. You need to process it to extract the really, really interesting stuff to get the full power, like human with a sword. So what's the solution? Maybe regular expressions. There are some services out there like the PasteSource on Twitter or Pastemon on LinkedIn. They're relying on regular expressions to find interesting stuff. Okay, works sometimes. I mean, in my test set, I tried some regular expressions for different hash types, like MD5, SHA-1, also sorted ones, and I found more than nearly 8,000 pastes where these hash types are found. But the problem is that these hashes are not always real hashes when it comes to leaks. Also, like torrents have hashes like MD5s or whatever, like URLs. Or you just have some dumps or whatever, which is totally unrelated to any leaks. Source code where stuff is detected by regular expressions. These are just some examples from LinkedIn and PasteSource. And also some encrypted PHP stuff. So regular expressions are nice, but the problem is you have a lot of options. When you just look it up at these two services, you will clearly see that this is not really working out. So additionally, you also have to support a large collection of different regular expressions. So first you think, okay, what am I interested in? Create some regular expressions. You need to update it when you're interested in more stuff. You need to extend it, you clean out the old stuff, which is not interesting. And you always have the problem that on one side you have a lot of false positives, so you get a lot of trash. And on the other side, you may miss the interesting stuff because you don't have a good regular expression to find it. Okay, so you have to evolve a bit more. So you can utilize regular expressions, but you have to do more. Like you have to detect the structure, detect the content type, detect similarities. That's a very interesting thing. I used in the proof of concept kind of fuzzy hashing based on the idea of spam. I don't know if you know this. It was created to detect spams, like similar emails, to remove spams, of course. But this is quite easy to do, like just compares, it creates a hash based on blocks, and then you have the ability to check the distance between different files, or paste in that case, and see the similarity between different files. So you can create some kind of clusters. And this is what I've done, of course. In my case, more than 100,000 clusters were created. I mean, if you compare it to the amount of paste, it's quite a lot. But when you have a look at the interesting stuff, just removing all the one paste clusters, you clearly see that there are quite a lot of big clusters, like this several thousands or several hundreds of pastes which go in the same direction, which is quite interesting because you can use this in an evolutionary approach, like you create it once and just grow your cluster size, and the more paste you get, the less will the amount of clusters grow, and you will have more bigger clusters of similar files because a lot of stuff is quite common, which is pasted regularly on these services. So this is one of them. Additionally, you have to check the content and the structure. I mean, I started creating new rules for file type recognition fiber. I didn't want to waste my time with updating the file database or genome DFS database, because the pastes are, as I said before, completely different to regular files. So I tried to spot common stuff which is used in, for example, Ruby source code, C source code, Java, JavaScript, whatever, to have these different differentiation between the different pastes to check out if it's, for example, source code or other stuff. And also to recognize the structure. Like not only having a look at the content itself and processing the content, but how is the paste created? Like if it's all one word per each line, for example, so it's clearly a list when you have 100 lines and in each line is just one word, it's clearly a list. And then you just have to check if it's maybe a list of email addresses or random words, which may lead to some leaks or something else. So I just correlated it, and there are quite a lot of bigger clusters in this. That's maybe a better view of that, where you can see that here are the file types, and on the others are structures. That there are some big clusters and some smaller clusters, and you see that you have a lot of lists, for example, which go in the same direction, and then you can process based on the structure and content type, and also on the clusters, so multi-stage approach in this way to go to a better way of finding the interesting stuff. Okay, the workflow in general, it's just like finally crawling, processing, extracting the interesting stuff, creating a word list, and use it. And in principle, that's so easy after some research. Still, there are some pros and cons on this approach. Like the good things are when using paste services, you have high diversity when it comes to create word lists out of. So you have a lot of different words, like slang words you can get in some chat logs. You also get interesting stuff maybe from specific source codes, unique words which may be used in some passwords, parts of books, text, whatever. You get all kinds of different languages here because there is no limit. I even seen some Korean and Japanese stuff, so open man. You have non-common data you won't directly find at some other sources like when you're specific at one resource like Wikipedia or IRC logs, which is very limited in the set of what data you get. Here you get just everything. You also get phrases and sentences fully if you're interested in it. You have a constant flow of new data, which is very, very interesting. At the moment, I collected more than 15 million pastes. 15 million. And it's increasing. I mean, it's every second just more and more and more. But I do not only go on one paste service. This is a very important thing. Scaling up is one thing, like to be able to catch all the data from one service, but scaling out to use more paste services, different sources, creates bigger diversity of what stuff you get. So if you're interested in that stuff and want to utilize it, don't only go for Pastebin because everyone is going for Pastebin. There are even more interesting other paste services out there where, the cool stuff is hosted, which is not so common. The bad thing on this is, of course, as you've seen, you have to invest a lot of time and resources in creating a crawler and also in the process. I mean, this is, you cannot say there is a general approach where you can just create a tool, release it, and that's it, and everybody can use it, because everyone may have different interests in what he may get out of these. My general approach is not only using it for WordPress or stuff in that area. That's just one part of a bigger picture when I started it back then. So you clearly have to know what's your target using all this data. And don't just rely on these simple tools like doing Liget magic like what Mark Zuckerberg did for his first project. So go directly in an intelligent approach and think about what you're doing, what I showed you before, and what you want. My future for my project is going even bigger. I have some new servers and I will create something like, now I'm using this password big data, yes I said it, which means creating a bit better database and processing environment to be able to keep up with all of these big stream of data and also be able to look back in the past. So when you today have something new which is interesting for you, that you can just look in the past and utilize the stuff you already collected and store it and get it out and also to get more. So going out for more paste services at the moment, at 5 different ones, and as you've seen there are more than 100, so there's quite a lot of space to improve this. The problem here, of course, is not every paste service is easy to crawl. So some have public indexes where you can see what new stuff comes in, others don't have it. So you need to think about maybe using search engines or Twitter or other stuff to get to this stuff, to the other paste services without index, and also, which is very, very important, some paste services are used as referrers. Like you get a paste, and in this paste are URLs referring to other paste services with the paste which the content you're interested in are hosted. So it's not only about getting all the paste, extracting the words, creating the word list. You also have to think about extracting and parsing the URLs and stuff which is inside the paste to be able to keep up with the interest. Because this changes a lot. Like Pastebin just recently announced that they will be more harder against leaks. So when Pastebin spots leaks or sensitive privacy data, they will just delete it. And this is, of course, again, something where the guys who do the leaks just go to other paste services and paste it there. Yeah, that's it from my side. I've tried to be in time. to make it easy and smooth. If you have any questions, just drop me an email or my Twitter account, or I'm here. So next week Thursday, so just talk. Thanks.